All right, let's cover our next category. So we just saw traversal, BFS and DFS. Now we are going to cover this shortest path problems. There are a lot of problems in this one. We'll start with our first one. So whenever it is asked that find the minimum distance from source to destination, or minimum time or cost, so whenever this is coming, most of the problems will fall under this category, and there are actually these different combinations, you can say, which we need to think of to fix an algorithm. First we'll start with the first one, which is where our graph is unweighted, which means that edge is kind of not having any weightage. It's not like if you take path A and path B, there are different weight or cost or any time attached with that edge. If that's the case, and we are to find out the minimum distance, or fastest way to go from source to destination, that is where our simple BFS is good enough. For this particular, to practice this, I picked a question which is very famous in interviews, plus there is a twist in this one. This is a multi-source BFS. This will be different from what we did in our previous videos. So let's jump to the question on LeetCode. We are having a grid like this, where 0 means there is nothing, 1 means a fresh fruit is there, and 2 means a rotten fruit is there, right? And whenever a bad fruit is next to any fresh fruit, that fresh fruit will also become bad after 1 unit of time. You can call it like after 1 minute or 1 day, right? So we have to calculate after how many days all the fruits will become bad. It's just that if they're not next to each other, then the fresh fruit will kind of stay fresh, or it will just stay fresh. There are no other conditions which can make it bad. Okay, the thing is here that there can be more than one bad fruit in the given grid, right? That can also be our starting phase. All right, so let's take this matrix. So for this one, I'll draw this matrix. Let's suppose this column is having not the fresh fruit, the other ones are having fresh fruits, and then fresh, here not fresh, not fresh, 1 1 1 1 1 1. Okay, so now by default, this is a special question. This is not a standard BFS. This is actually multi-source BFS. This is a category in itself where so many questions come. By default, if we are used to of doing BFS like we did in our number of island question, what we do is for every cell, like for this one, we will check if this can be our potential root, right? And then we were doing a BFS that we can do here also. So if I'll do a BFS from here, ultimately I will check both the neighbors, and then this neighbor and this neighbor will become our, you can say, bad fruit in 1 unit of time. Then if I'll continue that BFS with this particular source, the first one or root, then the next fruit will become bad fruit in next day, right? So for it, the answer will be 2. Like in 2 days, this will become bad fruit or rotten fruit, right? This is how we will continue doing it. problem with this one is when we'll continue and come back to this particular cell, right? My second row and third column. Well, when we will come to this, we will realize if we are doing a BFS here, first is you can say neighbors were already visited by now. So either we have to unvisit them, or we can also think of, okay, if now new route can give me a better time, like for first row and third column, this particular cell, because the root is neighbor itself, this can become bad fruit within 1 day. So answer will be, there can be a better answer, which will be 1, right? That means we can do infinite number of times, or you can say multiple number of times we have to process the same cell if we are going with the brute force BFS. Now I'll jump to what is the technique behind these kind of questions where multiple source or root nodes are already given to me. In this case, we don't need to go to every cell and do a separate BFS. What we can do is all my source node, which is these marked 2, these by default I can push into my queue upfront. So all these, obviously position of these, which is like 0, 0 is 1. Then you have 1, 2 is second. And so this is 0, 1, 2, 3, 0, 1, 2, 3. And then my 3, 3 is another one. So these upfront I pushed into the queue, and from here I will start my from here I will start the BFS. Now when I will do the BFS, so now I will do my regular BFS. In my regular BFS, first I will pop out the first element, right? The queue will not end here. Yeah, I will pop this out. And what are the neighbors? So now I'm having 2 neighbors, which is 1, 1, 0, 1, this one, and 1, 1. So I'll push these 2 into my queue because the time these were already bad fruits. So for all of them, the answer was 0. Now 0, 0 is coming out of the queue and pushing 2 neighbors into the queue, which is your 0, 1, second column, and first row 0th column, 1, 0. And for both of these, the time is 1 day. That also I'll push into the queue. What is the answer? So this is gone. Now 2 neighbors are here. Next is I will pop out whatever is there into the queue. So now I will pop out 1, 2 out from the queue, which is my this 2. And that is how the magic is happening, that I don't need to do the BFS from one source at once, right? So if you see now, for the neighbor of this one, best answer will come first itself. So I don't need to recheck it whether some other source is doing a better, producing a better answer for me or not. Okay, so that is how we'll complete. So I'll do it for this source as well. So we will pop out 1, 2, and 1, 2 will push 0 column, 0 row and second column with 1 as time. And then it will push another one, which is first row, first column, which is this guy. This is also pushed with 1 time because root node was at 0. So this is popped out. These 2 neighbors are in, and one more neighbor which will come is here, which is your first row, last column, third with 1, and the bottom one, because we are doing 4 directional, right? So bottom one, which is your second row and second column, also with 1 time, right? So these 4 neighbors are pushed. Now we will pop out similarly the 3 3 and we'll push the other ones. So if we'll continue in this fashion, we will push every fresh fruit cell into the queue. We will pop them out once and we will always get the best answer for that particular cell in first push itself. So we don't need to recheck it again and again. So this is called multi-source or multi-root, whatever you want to say, multi-source breadth first search. Okay, this is a category in itself, and this question itself, rotten oranges, is very frequently asked question in Amazon and other companies. Okay, so we can continue our BFS with this approach now. Okay, so let's attempt this one now with the new approach of multi-source BFS. That means queue, I'm assuming, okay, I can have queue here, or let's suppose the queue is initiated by the original question. So I can imagine that here is a self.queue, because whoever is the caller can already push all the roots in my answer. Okay, so let's start from here first. So I would say that I need another matrix. I'll call it time, because what we need here is time. That what's the maximum time taken by to become, so that all the fruits are not fresh in this time. So I'm calling it a time matrix. And so here I'll say by default you can say time is 0, and it doesn't matter because we need the maximum. So for I in range of, this is m into n, right? So I in range of, I'll get m first. M is my length of the grid and n is my length of first row in the grid. Okay, so same way for j in range of m, I'm just initiating an empty matrix. Now second thing what I need is a queue. So let's call it self.queue is equals to dq for every cell. Now for I in range of m, for j in range of n, we said if in my grid this is not a fresh fruit, then what I need to do is I need to push it into my queue. So self.queue dot append ij I comma j comma 0 is the cost or time for those fruits to become rotten fruit. By default they are rotten fruits, so I'm just simply pushing it as it is. That's it. So all the sources are already added. Now if I just do self.bfs on this, where I actually do not need to pass anything, let's just pass the grid. Start I'm not passing because start is already there into the queue. So grid is one thing which I can pass, and that's it. It will manipulate the time one, right? Now answer is the maximum thing I'm looking for. So by default, let's keep it 0. And for I in range of m, we just need to check j in range of n. So now we will check if still there is any fruit which is fresh in the original grid. So we'll say if my grid, and because I was passing grid, so let's not actually pass it, do it like self dot grid is equals to grid, so that whatever manipulation is happening inside BFS, we should be able to check it here. So self dot grid at I comma j is equals to 1. If any of the fruit is still fresh, then we can simply return -1. That it's not possible to make all the fruits bad. Now another thing we need to check is, now what is the maximum? If this is not the condition, then my answer is equals to maximum of whatever is answer so far, comma, self dot time of this particular cell. So whichever is maximum value, I just need to get it. In the end, I need to return answer. Now let's change our BFS as per the requirement. So do I need visited this time? Actually no, because I can simply check. So whichever I will, this time I'll use that visited array, my grid itself to check the visited. So by default root is already there. So I will simply try to do it. Now what I will get from here is I comma j, which I already pushed, and time so far, that is I'm popping out from my queue. Now from neighbors, because my neighbors are like 4 directional, so this we did earlier, we can use our direction array. This is for 4 directional DIRs. Now that means I need to check in all 4 direction. So we used our 4 directional loop like this. What this will do, so it will get in all the 4 directions from the current cell, right? I am doing, so that is where we were calling it dx, dy, and time. So sorry, xy. So I can call it now I comma j. So new x, new y. So I need to check if they are like valid or not. So what is my rows here? Row is equals to length of my grid, self dot grid. Columns is length of first row, grid 0. Yeah, gotcha. So I got my boundaries here. Boundaries are checked. Now another check which I should do. So first is if my new x and new y is within the boundary. Another thing I need to check if and my in my grid in new x and new y, if this number is 1, which means if it is a fresh fruit, then only it is a valid neighbor where I need to go. And for visiting, what I can do, if this was a fresh fruit, so we will convert this new x, new y to a bad fruit. And then we are appending a tuple where we will append new x comma new y, whatever was the time of the root plus 1. Okay, so that is how the time will increase. One thing which we are missing is that we need to push it into our metrics, time metrics. So self dot time new x, sorry, not new x, I j equals to time. So this we are updating into a time matrix. So we are keeping a separate matrix where we are storing that time from which we are getting what is our answer. So what we did so far, direction array we are using to go, like let's suppose this is my route, current route. So I need to check up, then next, then down, and then left. This is where it is helping me, -1 row and 0th column. Same way we are just doing a simple addition. So to check all the neighbors we are doing this, and then we are checking whether this is a valid neighbor, right? Only to fresh fruit we need to go if this is within the boundaries of this matrix. Then we are using the same grid to check to use it as a visited array as well by manipulating the values within it. If this is 2, obviously you don't need to go into that neighbor also. So only 1 is the valid case. Now everything looks fine. Let's see. Okay, here I am passing many things because this is copy pasted BFS. So looks like it. Okay, self.q, same thing will go here. Cool. Looks like the basic cases are working. Let's just submit it. Perfect. So yeah, it is working. Let's now try to do the analysis of this algorithm. First thing first, we are going over the entire grid, means every cell. So m into n, this loop, it's no brainer to say that this one is giving us m into n, our time complexity. Now we are appending everything into the queue, and then we are calling the BFS. Here again we are doing m into n, so m into n is the complexity, and then because we are calling BFS separately, let's check what is happening in this one. So in this one, we are in worst case scenario, we will push every cell into the queue, right? So this is order, and every cell means nothing but m into n only. But because this is not happening inside the loop, it is a separate one, so this is also an addition. So this loop is m into n again, means every cell. Inside that we are having this array, but if you see, this is like it will only run for this static array. That means only 4 times. So this you can think of 4 instructions are written one after another inside my while loop, which are of constant complexity. So hence this you can consider as constant, like these lines written 4 times, and pushing it into queue is also constant, right? So this overall is also just m into n. So overall time complexity of this is m into n in worst case. Now coming to space complexity, we are using this matrix to store our time, which is obviously same size as grid. So m into n is the space complexity, plus we are using the queue, which is of same size that every cell can be pushed. But that's not the reality, but yeah, we can say because only one level can be pushed. But yeah, m into n is the worst case time complexity as well. So yeah, multi-source BFS, this is one you can say question of it. Do practice other questions as well, and we will move to our next category in our graph. Thank you.